Imagine our planet, Earth, a beautiful blue marble spinning in space. We walk on its surface, we build our cities here, we live our lives. But beneath our very feet, deep down, lies a world of mystery, a place of incredible heat and crushing pressure. This is Earth's core. For a long time we thought we knew what was there. Mostly iron, we said, and nickel. But Earth, it seems, has been holding on to a rather shiny secret. A secret treasure vast beyond imagination, locked away in its very heart. This hidden treasure isn't just a small find, it's a fundamental part of our planet's composition. Think about the early Earth. A chaotic, molten ball of rock and metal. Heavier elements like iron and gold naturally sank towards the center. They were pulled down by gravity. This process, called differentiation, shaped our world. It created the layers we know today, the crust, the mantle and the core. And in that core, the heaviest, most precious elements concentrated. So, what is this secret treasure? It's gold and platinum. We live on a planet that has, quite literally, a heart of gold. This isn't poetry, it's geology. Let's talk about scale. How much gold are we really talking about in Earth's core? Prepare to be amazed. Scientists estimate there's enough gold down there to cover the entire surface of the Earth, not just a thin layer, but a coating several feet thick. Imagine that, the whole planet wrapped in a shimmering blanket of gold. That's a mind-boggling amount of treasure, far more gold than humanity has ever mined, or ever will mine from the crust. This isn't just a few nuggets, it's an ocean of molten gold mixed with iron and other elements. How did all this gold end up in the core? It goes back to Earth's early days. About 4.5 billion years ago, our planet was a hot, molten mess. Asteroids and planetesimals constantly bombarded it. This was a violent time. As Earth grew, it heated up, the rock melted, and because gold is very dense, very heavy, it began to sink. Along with iron and nickel, it trickled down through the lighter silicate rocks, eventually reaching the very center of the planet. This process took millions of years, a slow gravitational sorting of materials. The core, therefore, is not just a dense ball of iron. It's Earth's ultimate vault, holding the bulk of its precious metal wealth. Earth is a complex system. So, this vast golden hoard is locked away. Or is it? Recent scientific discoveries suggest something astonishing. Some of this core-bound gold might be leaking, slowly making its way towards the surface. How could this happen, and how do scientists even know? It's a fascinating piece of detective work, using the Earth itself as a laboratory. Scientists aren't digging for gold directly from the core. Instead, they are looking for subtle clues. Chemical fingerprints left behind in rocks. These rocks have traveled from deep within the Earth. The key evidence comes from studying isotopes. Isotopes are different versions of the same element. They have the same number of protons, but different numbers of neutrons. Scientists have been looking at isotopes of elements like tungsten. Tungsten has some isotopes that prefer to be in metal, like the core, and others that prefer silicate rock, like the mantle. When the core formed, it developed a unique tungsten isotopic signature. If material from the core mixes with the mantle, it should carry that signature. And that's exactly what some researchers are finding. They've analyzed rocks from places like Hawaii and Samoa. These islands are formed by mantle plumes, giant upwellings of hot rock from deep within the Earth. Section 4. No El Dorado. Here, the reality of leaking gold. Now, before you start dreaming of a new gold rush or planning expeditions to volcanic hotspots, let's be very clear. This leaking gold is not going to make anyone rich. Not directly, anyway. The amounts of gold migrating from the core to the surface are incredibly small. We're talking about parts per billion or even less. These are trace amounts, microscopic particles, dispersed within vast volumes of rock. It's not like there are veins of pure core gold suddenly appearing. That's the stuff of fantasy. Think of it like this. Imagine a giant swimming pool. The core is that pool full of gold-infused water. The leakage is like taking a single eyedropper of that water and mixing it into another, even larger swimming pool representing the mantle. Then a tiny splash from that second pool reaches the surface. The concentration of the original gold water would be minuscule. So, while the total amount of gold in the core is enormous, the amount that actually makes it to the crust through this leakage pathway is tiny. And it's spread very, very thinly. The gold we currently mine from the crust, the gold in our jewelry and electronics, that gold has a different story. Most of it arrived much later, after the core had already formed. It was delivered by meteorite impacts during a period called the Late Heavy Bombardment. This is why gold is rare but still findable near the surface. The core's contribution, this slow leak, is a separate, much smaller phenomenon. Section 5. Beyond the glitter. What this discovery truly means. If this leaking gold isn't about getting rich, then why is it so important? This discovery has profound implications for Earth sciences. It changes how we view our planet. For a long time, the core and mantle were seen as largely separate systems. Once the core formed, that was it, sealed off. But this evidence of leakage suggests otherwise. It points to ongoing interaction, a dynamic exchange between Earth's deepest layers. This is a big shift in thinking. It means Earth is more interconnected internally than we previously thought. This understanding helps us refine our models of planetary formation and evolution, not just for Earth, but for other rocky planets too. How do cores and mantles interact on Mars or Venus? Studying these processes on Earth gives us clues. It helps us understand what makes a planet habitable, how planetary magnetic fields are generated and sustained. The core-mantle boundary is a critical zone. It's where the metallic outer core meets the rocky lower mantle. What happens there influences the entire planet, from plate tectonics to the long-term climate. Furthermore, this knowledge could indirectly aid in resource exploration. While the leaking gold itself isn't mineable, understanding the large-scale movements of material within the Earth, like mantle plumes, can help us identify regions where other mineral deposits might be concentrated. Mantle plumes are associated with certain types of ore deposits. Knowing their origins and whether they tap into deep, chemically distinct reservoirs can provide new perspectives for geologists. It's about understanding the Earth's system as a whole and how its components work together. Section 6. The evolving Earth future echoes from the deep. What does the future hold for this line of research? We are just beginning to scratch the surface, or perhaps to listen to the whispers from the deep. Scientists will continue to hunt for more evidence, analyzing rocks from different geological settings from various volcanic regions around the world, looking for those telltale isotopic signatures. They will refine their analytical techniques, allowing them to detect even fainter traces of core-mantle interaction. Each new data point adds another piece to the puzzle, helping to build a clearer picture. Future research might also involve more sophisticated computer modeling, simulating the conditions at the core-mantle boundary, trying to understand the exact mechanisms of leakage. How does material cross that immense pressure and temperature gradient? What are the pathways? How much material is exchanged over geological time? These are complex questions, requiring powerful computers and clever algorithms. But the answers will shed more light on the inner workings of our dynamic planet and how it has changed over its long history. This discovery also reminds us that Earth is not a static museum piece. It is an evolving planet. The processes happening today, like mantle plumes and plate tectonics, are part of a long continuum stretching back billions of years. And they will continue into the future. The slow leak of material from the core, if it's indeed happening, is part of this grand planetary scale evolution. It subtly changes the composition of the mantle over eons, contributing to the Earth's ongoing geological story. A story that is still being written. Ultimately, the study of Earth's deep interior is a journey of exploration as profound as exploring distant galaxies. We live on this planet, yet there is so much we still don't know about what lies beneath us. Each new discovery, like the potential leakage of gold from the core, opens up new avenues of inquiry, new mysteries to solve. It fuels our curiosity and deepens our appreciation for the complex, wonderful, and ever-changing world we call home. The Earth continues to surprise us.